Good day, everyone. I am Alvin Bohol, and today I am going to discuss to you one of the topics in data communication and networking one, which is network types and topologies. At the end of this lesson, you are expected to discuss the three basic types of network: the local area network, the metropolitan area network, the wide area network, and describe the server client model and explain the different network topologies. And lastly, identify the different network protocols and communications. So introduction to network types and topologies. Network is a set of interconnected devices that makes communication, sharing of data, information, and resources possible. Meaning to say, through network, we are able to share, we are able to communicate, to share data, to share information and resources to other people. And this network has its basic types and topologies. So learning these different network types and topologies will help us to design and implement efficient networks that meet our specific needs. So now let's start to discuss one of the network basic types, which is the local area network or the LAN. So this is an example of a simple LAN connection. Okay. So a local area network or a LAN is an individual network that usually spans a single geographical area, providing services and applications to people within a common organizational structure, such as a single business, campus, or region. Therefore, a LAN or a local area network is a network that connects devices within a limited geographical area. Okay, so one of the great examples of a local area network is a home network, wherein devices like computers, smartphones, tablets are connected to a Wi-Fi router, which allows you to share internet access to print documents and stream media between these devices. Next is we have the wide area network or the WAN. So this is an example of a WAN connection. So wide area network or a WAN is a network connection between two or more LAN over a potentially large geographic distance. So communication between networks is called internetworking. And one of the best example of a wide area network is the internet, wherein it connects countless network worldwide, enabling global communication and data exchange. And last basic network types we have is the metropolitan area network. So this is an example of a metropolitan area network. A MAN or a metropolitan area network is usually interconnects a number of LANs using a high capacity backbone technology such as fiber optical links and provides uplink services to WANs and the internet. So a MAN's coverage can span between cities. So a great example of a MAN or metropolitan area network is a citywide network that connects government offices, universities, hospitals, and businesses. So this network allows for efficient communication and data sharing between these organizations. Okay, so now that we have learned the three basic types of networks, let us try to discuss and understand what is the client server model. So this is an example of a client server model. So Client-server model is a relationship between the clients and the server. So server have software installed that enables them to provide information and services like email or web pages to other hosts on a network. So example of installed applications or software in servers are the web servers, the email servers, the file server, and the database server. And the client, on the other hand, the client have software installed that enables them to request and display the information obtained from the server. So example of software installed by the client are the web browser, the email client, the file transfers client, and the remote desktop client. So and since the client server model discuss about the relationship between the client and the server, this is how it works. So for example, a client is asking an information to the internet. Okay, so he tend to browse to the web browser, for to the browser such as in a Chrome application to find something. Then the job of the server is to provide what the client is asking. Okay, so that is how client and server model works. So now since we already learned the relationship between the client and the server, now let us discuss the arrangement of computers in a network, which is called a network design or topology. So network topology or design is the arrangement of computers in a network. It defines how these components are connected and interact with each other. There are there are five common network topology, which are: first we have the bus topology, the ring topology, the star topology, the mesh topology, and the hybrid topology. Now let us discuss what is bus topology. So this is an example of a bus topology. Okay, so a bus topology is a network topology in which every computer and network device is connected to a single cable. Okay, now let's try to create a simple bus topology using a Cisco packet tracer. Okay, so this is how to create a bus topology. So this is just a sample configuration. So first we need to add two switches and four PCs. Okay. Next is the four PCs. The four PC. Then the next step is to connect cables. So from switch to switch and PC1 to switch. So for example, PC0 to switch 0, PC1 to switch 0, then PC2 to switch 1, and PC3 to switch 1. Okay, so we are using a cable, a copper straight through connection to connect PC to the switch. Then let us connect the switch using a copper straight through connection. So after this, we need to configure our PC 0 to PC 3. So just click the config, then go to the fast Ethernet, then IP4, and enter the sample address and the subnet mask. So do the same with PC1 to PC3 and make sure that the IP address is unique and not the same. Okay. Okay, now let us try to check if the connection is successfully configured by adding a simple PDU to any PC. Okay. Okay, you can follow the on-screen steps on how to create a best topology and how to configure it and how to check if the connection is successful or not. Okay, so if the connection is successful, it means that the topology or the best topology is configured correctly. However, if the status is failed, this means that there is something wrong in the connection or in the configuration. So this is how we create or how to create a best topology. So following these steps will help you or will guide you to create a simple best topology. Now the next topology that we are going to discuss is a ring topology. So this is an example of a ring topology. This looks like a ring, okay? So a ring topology is a topology that forms a ring such as each computer is connected to another computer with the last one connected to the first. So how to do this? Well, let us try to watch the video on how to set up or to create a ring topology. Okay, so this is how to create a ring topology. So again, this is just a sample configuration on how to create our ring topology. So in our sample, we add 7 switches and 7 pieces to design like a ring. Actually, you can create a ring topology by using, I guess, 4 PC, but Since this is sample, I just create a ring topology with 7 switches and 7 pieces. Okay, let's try to use a cable. Okay, so we need to connect each PC to each switch for us to create a ring topology. And then we need to create, we need to connect each switch to each other. So switches to switches. So now let us configure each PC by using our sample IP address. So again, make sure that the IP address is unique to each PC. Okay, so after configuring our PC IP address, let us try to check if our connection is successful or not. Okay, when the last status is successful, this means that our connection, such as the cable, the configuration, is properly installed or configured. Okay. Okay, so since the status is successful, this means that our ring topology is properly configured. So now we will proceed to another topology, which is the star topology. So this is an example of a star topology. So when we say star topology, This is a type of topology where all the computers are connected to a single hub through a cable. Okay, so let's try to create a simple star topology using our Cisco packet tracer. So we need to add a hub or a switch and then PC. So this is just an example, a sample configuration on how to start or to create a star topology. Okay. Okay, so after this, let's start to configure the IP address of the PC0 to PC9. Okay, after configuring our PC's IP address, so let's try to check using a simple PDU. Okay. Again, if the status is failed, this means that our star topology has a configuration error or a connection error. But if the status is successful, this means that our star topology is correctly configured. So as we can see, our the status is successful, but let us try to test again using all PC to another PC. Okay, let's try if all pieces are configured or all the cables are properly configured and all pieces are properly configured. Okay, so as we can see, this one, so all, so the status are all successful, which means that our star topology is successfully or correctly configured. So now our next topology is a mesh topology. So this is a mesh topology. A mesh topology is a network setup where each computer and network devices is interconnected with one another. Okay, so this topology setup allows most transmissions to be distributed even if one of the connections goes down. So now let us try to create a sample mesh topology using our Cisco packet tracer. So we need to add 5 switch or hubs and 5 PCs. Then let us connect them to each other. So this is not a star topology, but a mesh topology. Okay, we will connect them. Okay, so all switches are connected to each other. Then let's add 5 PC to each switch. Okay. Okay, connect them to each PC using a copper straight through connection, or we can use the automatically choose connection type connector. So after this, we need to configure each PC by entering its unique IP address. So this is just a sample IP address, okay? Okay, go to config fast internet. Okay, make sure that IP address for each PC is unique because you can enter the same IP address with two different PC. Okay, then let us try to see if the connection is successfully configured or not. Okay, add a simple PDU and let us observe how or okay how the envelope passes through the cable to reach the destination. Okay, so the destination is EC3. Okay, so the last status is successful, which means that our mesh topology is working properly and there is no connection or a configuration error. Okay, now let us discuss the hybrid topology. So our last topology, so this is an example of a hybrid topology. So a hybrid topology is a network structure that combines two or more different types of topologies, such as star, ring, bus, or mesh. So this topology setup allows most transmissions to be distributed even if one of the connection goes down. So let's try to create a hybrid topology using a Cisco packet tracer. So again, this is just a simple hybrid topology. Okay, we will create a ring topology. And now we have a ring topology. Okay, so we have a ring topology. And the next is a mesh topology. Mesh topology. So we connect a mesh topology to a ring topology, which means this is now a hybrid topology. So because hybrid topology is a combination of it's a combination of two or more topology. Okay, let's start to configure the IP address of each PC. Okay, now that we have configured each PC, let's try to test if our connection and cables are working properly. So let's add again a simple PDU. Okay, so after sending the message, it will go back to its destination. This is here, then here. Okay, and let us observe the status here. So this is in progress. Let us see if it will become success. Okay, so after receiving the message from the destination, our status became successful, which means that our connections and configurations are properly configured. Okay. So now that we have learned the different network topology and how to configure it using a Cisco packet tracer, let us discuss then the network protocols and communications. So network protocols and communications. So protocols, so these are rules and that govern communication. It is made up of a group of related protocols that are necessary to communicate via electronic means. So without protocols, the interconnected world we rely on would not be possible because they enable everything from simple file transfer to complex online service and application. Okay, so this is how protocols are important in the communication. Now let us discuss what is network protocol. So network protocol is a describe processes such as the format or structure of the message, the process by which networking device share information about pathways with other networks, how and when error and system messages are passed between devices, and the setup and termination of the data transfer sessions. Okay, then we have a protocol suites and standards. So organizations such as an electrical and electronic engineers or the IEEE and Internet Engineering Task Force or the IETF defines the standards we use in IT today, particularly for the network technologies. So here are some of the commonly used protocols. Okay, so we have a hypertext transfer protocol or the HTTP. Number two, the transmission control protocol, the TCP, the inner network protocol, the IP, and lastly, we have the multiple protocols. So let us discuss first the hypertext transfer protocol. So hypertext transfer protocol, it is a common protocol that governs interaction between web server and a web client. It also defines the content and formatting of the request and responses between the client and server, where both the client and the web server software implement the HTTP application. Thus, HTTP relies on the other protocols to govern how the messages are transported between client and the server. So next is we have the transmission control protocol or the TCP. So Transport Protocol handles the individual conversations between servers and clients, and not just web servers and web clients, but also that TCP segregates the HTTP messages into smaller pieces called segments. So TCP is responsible for controlling the information exchange between the servers and the client, such as the size of data, the flow control, and how much is sent and received, and the reliability on which the sequence numbers are monitored in case of lost or missing something. Next, we have the inner network protocol or the IP. So IP transfers the formatted segments from TCP, encapsulating them into packets and designates the appropriate source and destination addresses from the original source address of host to the final destination address of host. So IP is used by router in selecting the best path to the destination host. Lastly, we have a multiple protocols. So multiple protocols, so the messages received by the host usually contains multiple protocols plus the actual data which the application header or HTTP may or may not exist. Okay, so following protocol suites and standards is essential for ensuring the smooth functioning of modern communication networks. By promoting interoperability, security, reliability, innovation, and global connectivity, these standards play a vital role in shaping our interconnected world. So now let us discuss the fundamental concept in computer networking, which is the encapsulation and the decapsulation. So encapsulation is a process to hide or protect a process from the possibility of outside interference or misuse of the system while simplifying the use of the system itself. Also, mix one type of network data packets to other data types. In computer networking, encapsulation is the process of taking data from one protocol and translating it into another protocol, so the data can continue across a network. Then decapsulation, it is the inverse of the encapsulation process. So encapsulation is the process of wrapping the data, while the decapsulation process is a process of opening packs. So encapsulation and decapsulation are fundamental concepts in computer networking. So they are responsible in preparing data for transmission across a network and then restoring it to its original form at the destination. Okay, so and here ends our discussion about the network type and topology. So to sum up our discussion, we have learned the importance of learning and understanding the different network types and topologies. Why? Because it will help us to design, to implement, and troubleshoot network based on our specific needs. So for example, we have learned the difference between the local area network, the wide area network, and the metropolitan network. And that local area network is a network type which covers a small geographical area such as home network. Then, when we say wide area network, this is a network type that covers a large or wide geographical area such as the internet. So moreover, when it comes to metropolitan area network, so its coverage can span between cities. Furthermore, from this discussion, we have learned the relationship between the client and the server, and that client uses software like Chrome browser to make a request to server, and that this server in response uses web server to grant the request of the client, such as providing information and services like email or web pages. Then we have learned the different network topologies and able to configure using the Cisco Packet Tracer. Lastly, we are able to identify the different network protocols and communications. So here end our discussion and thank you for listening.